Hi ladies, in this video we're going to do 5G, communications and connections. I've just finished doing the video for 5F, and oh my gosh, I just made so many, not errors, but you can tell it's the end of the day. It's 4:30, I'm looking outside, the sun is shining, dog was just barking. There's always helicopters above. No, I don't live in a high crime area. I just live next to an airport, so it can get quite noisy hearing all the helicopters go overhead. But anyway, you probably aren't very interested in that, so let's move on to 5G. Okay, so social networks and communication connections can be represented in a matrix. So looking at this diagram is what we call a network diagram. So when we do networks, if we do networks, you will get a better understanding of what networks is or how this diagram works. But in matrices, you've got a diagram and you can simplify it. So we've got this diagram just shows the communication between a group of friends. So you got Vicky, Kathy, Steve, and Paul. So a double-headed arrow connecting two names means those people communicated with each other. If there are no double-headed arrows connecting two people, it means they did not communicate. So if we just look here, everyone has communicated except for Vicky and Paul. So hopefully they can mend their relationship and they can communicate once again, but at this stage they are not communicating. So these links are called one-step connections because there is just one direct step in making contact with the other person. So let's say Vicky wasn't talking to Paul. So Vicky might say to Kathy, "Oh, can you tell Paul that I'm not happy that he didn't bring the bins in last week," or something like that. So that would be then two steps. So Vicky can still communicate with Paul, not directly, not in one step, but she can via Kathy or through Steve. And that is a two-step communication. Okay, I think I'm getting off track here. So I'm going to keep reading. Record the social links as in a matrix N using the first letter of each name to label the columns and rows. Explain how the matrix should be read. Okay, so we're not really doing two-step here. Maybe we are later on. And my dog's in the background shaking. So we've got helicopters. We've got my dog shaking her head. Not because she's disappointed in me. I hope she's not. Just, that's what dogs do. All right, so we're going to set up our matrix. So I've got V for Vicky, K for Kathy, you get the gist, okay? And then up here, it's who they've communicated with. Now, Vicky, there's no arrow for Vicky, so Vicky's not communicating with Vicky. You can only communicate with one other person, obviously. I don't know, can you communicate with yourself? So we're going to put zeros down there because Vicky's not communicating with Vicky, Kathy's not communicating with Kathy, Steve's, yeah, you get the gist. Now, let's look at this. So Vicky is communicating with Kathy, so we'll put a 1. And the arrow is two ways, so I'm going to put a 1 there as well. Okay, so Vicky communicates with Kathy, Kathy communicates with Vicky. Vicky also communicates with Steve, so we'll put a 1 there and a 1 here. Now, Vicky doesn't communicate with Paul, so we're going to put a 0 there and a 0 here. Okay, let's move on to Kathy. So Kathy, we've already got a 1 there. But Kathy also communicates with Steve and she communicates with Paul. So remember, it's going to be symmetrical along the diagonal. And then Paul communicates with Steve. Okay, so the only 0 we have there is for Paul not communicating with Vicky. And it's a matrix, so we got to put in our square brackets. If we don't have square brackets, it's not a matrix. Okay, so I'm just reading the question. Record this. Okay, so explain how the matrix should be read. So if we read across in the rows, Vicky can communicate with Kathy, Steve, but not Paul. Kathy communicates with Vicky, Steve, and Paul. And Steve communicates with Vicky, Kathy, and Paul. And Paul doesn't communicate with Vicky, but he communicates with Kate, Kathy, and Steve. Cool. Explain why there is a symmetry about the leading diagonal. Okay, so there is a symmetry because, first of all, the arrows are going both ways. Okay, so that indicates that people are communicating with each other. And people aren't communicating with each other. So Vicky isn't communicating with Paul. So it's not like Vicky's just, yelling at Paul and Paul's not responding. So there's not a double headed arrow there, but everyone else, they're communicating with each other. So that's why it's symmetrical. What information is given by the sum of a column or row? So I think I've already said this. So it's how many people they can communicate with. So if we did the sum of this row, Vicky communicates with 2 people, Kathy communicates with 3, Steve communicates with 3, and Paul communicates with 2. So I'm just adding up the rows there. All right, N2, so this is what I mean by two-step dominant communications. Sorry, I was using networks lingo there. So two-step communications between people, namely how many ways one person can communicate with someone via another person. So this is what I was talking about before, two-step communication. So if I go back here to our diagram, I'm just going to put my letters in again. All right, we're going to have zeros along the diagonal because, again, you can't really communicate with yourself. All right, let's go Vicky, and then we're doing 2 steps. So let's say Vicky couldn't communicate with Kathy directly, but she could go via Steve. She could go 1, 2. Okay, so let's say Kathy wasn't talking to Vicky directly, so Vicky might put a message through to Steve, and she can only do it that way. The only way she can get to Kathy is through Steve. So there's only one way she can do that. And because the arrows are double-headed, it's the same in reverse. Okay, so it's going to be symmetrical. All right, let's look at Vicky and Steve. So Vicky can chat to Steve via Kathy, but no one else. Okay, she can't go via Paul because that would be 3 steps. So it's just going to be 1 here and 1 here. And Vicky and Paul, Vicky can go to Paul either through Steve or through Kathy. So there's 2 ways she can get to Paul, and Paul has 2 ways to get to Vicky. All right, let's move on to Kathy. So Kathy can contact Steve via Paul or via Vicky. So there's 2 ways she can contact Steve, and the same in reverse. And then Kathy and Paul, Kathy can only go through Steve. Okay, so let's say if that line was missing, Kathy can go through Steve, and then Paul can also go through Steve. There we go. Just trying to figure out where I was going to put that one. All right, and then let's do Steve. Steve can go to Paul through Kathy only, not through Vicky. And then we're done. Okay, so that's our 2-step dominance. So if someone wasn't talking, and I shouldn't say that because it's not really, I don't know, nice, but let's say someone wasn't talking to someone, you had to get a message through and you had to go through someone else, that's 2-step communication. Okay, use the N2 to find the number of 2-step ways Kathy communicate with Steve and write the connection. So Kathy can go to Steve 2 ways. She can, let's go back to our diagram. Vicky can get to Steve, no, Kathy can get to Steve either through Vicky or through Paul. So she can go Kathy, Vicky, Steve, or Kathy, Paul, Steve. Such 80s names too. Like, anyway. In the N2 matrix, there is a 3 where S column meets S row. This indicates that the 3 2-step matrices Steve can have with himself. Explain how this can be given a sensible interpretation. Well, I was saying they couldn't be communicated with, but I guess if you wanted to do that, we could put them in. But if you're communicating with other people, maybe we could do that. Let me just think for a sec. All right, so I just had a look at the textbook because this example is actually in the textbook. I would disagree. I don't think you can communicate with yourself. But the example they gave is if you were to contact the person and ask them to leave a message and the message got back to you. So that kind of, yeah, doesn't make sense to me. Let's just go and have a look at the diagram. So let's say for Vic, oh no, we're doing Steve. So Steve can communicate with himself by going, oh, okay, by going to Paul and then back to himself. And that would be if Steve gave a message to Paul and Paul had to call him back. Yeah, I don't think so. I think we'll just leave it as zeros for now. Okay, it's not going to be that ambiguous. I don't really like the sensible interpretation of that you leave a message and then they call you back. Yeah, I kind of see it as the number of ways you can get in contact with that person. But if you're thinking of the number of ways you can get in contact with yourself, I don't know, it doesn't make sense to me. All right, girls, we'll move on. Do those questions for 5G. If you need one, if you want to discuss this question, I'm more than happy to, but I'm just going to leave them as zeros. All right, bye.